Hello students. First of all, we will start with trigonometry. Today we will discuss measurement of angles. Okay. Now see how we measure the angle. In previous class, you have the idea that you used to measure the angles in terms of what? Degree. Okay. But apart from degree, we have some other units also to measure the angle. Okay. The first one is sexagesimal system. Sexagesimal system. The second one is centesimal system, and the third one is circular system. So three systems are there under which we measure the angle. First one is sexagesimal system, the second one is centesimal system, and the third one is circular system. Under these three systems we measure the angle. The first system, sexagesimal system, this is also known as English system. The second one, centesimal system, this is also known as French system. And the third one, circular system, this is SI system. Okay. So three systems are there under which we measure the given angle. Okay. Now see, as the name sounds, English system or British system, okay, this system of measurement was developed by Britishers. Okay. Hence this system is known as what? Sexagesimal system. This centesimal system, this is developed by France, hence it is known as what? French system. And this circular system is the SI unit of angle. Okay. Therefore it is known as what? SI system. Okay. See, this sexagesimal system is the most popular system of measurement of angles, and you all are familiar with this system. Here we measure the angles in terms of degree. Here the angles are measured in terms of degree. Under centesimal system, we measure the angle in terms of grades, and under circular system we measure the angles in terms of radian. Okay. So under these three systems we will measure the angle. Okay. One by one I will discuss all these systems, and then what is the relationship between sexagesimal system, centesimal system and circular system, that I will discuss. Okay. Now see, sexagesimal system is most popular system. Okay. And why it is most popular system? Because Britishers were the powerful imperialist country. Okay. As a result of which, okay, it has its colony in maximum part of the world, as a result of which its system, that is this degree system, it was most popular, or it become most popular. Okay. This centesimal system, this is unpopular system. Here the angles are measured in terms of grades, and this is what SI system. We know that what is SI system, we are familiar with the SI units. Okay. So see, we compare that degree with one right angle. Okay. One right angle is equals to 90 degree. Now let us discuss this sexagesimal system. Okay. Here, one right angle is equals to 90 degree. Okay, this is how we represent degree. Okay, one right angle is equals to 90 degree, and 1 degree, this is equals to 60 minute, and 1 minute is equals to 60 second. Okay, now we will understand that what is this minute and what is this second. Okay, now see, this minute and second has nothing to do with the time. Okay, this is the part of the angle. Okay, suppose that we have drawn 1 degree, this is more than 1 degree. Okay, suppose that, let us assume that this is what, 1 degree. Now we are trying to understand that what is this minute. Okay, now what we do, that we divide this 1 degree in 60 equal parts. Okay, see, this is 1 degree. Now what we do, that we divide this 1 degree in 60 equal parts. 1, 2, 3, 4, 5, 6 and so on. Okay, 60 equal parts. Now you can imagine, okay, that what will be the means one part. Okay, the size of one part, 1 degree is already small. Okay, when we further divide this 1 degree in 60 equal parts, a very small part comes into existence. Okay, and that one part is considered to be 1 minute. Okay, so 60 parts together, they combine, okay, to form this 1 degree, or we can say that 60th part of 1 degree, that is known as what, minute. Okay, so what is minute? Minute is the part of 1 degree. Okay, the 60th part of 1 degree, that is known as what, 1 minute. What we do, that first of all we draw 1 degree, then we divide that 1 degree in 60 equal part. Each part is known as what, 1 minute. So all together 60 parts, they combine to give 1 degree. So we say that 60th part of 1 degree, that is what, 1 minute. That is 1 minute is equals to what, we divide 1 degree by 60. Okay, and we say that this part is only what, 1 minute. So I hope that the concept of minute is clear to you all. Now move to second. Now 1 minute, already 1 degree is small. Okay, then we have divided that 1 degree in 60 equal parts. Okay, one part, okay, that is known as what, 1 minute. Now just imagine that how small 1 minute is. Okay, now what we do, that 1 minute is again divided in 60 equal part. Okay, and the 60th part of 1 minute, that is known as what, 1 second. That is when this 1 minute is divided by 60. Okay, then we say that the 60th part of 1 minute, that is equals to what, 1 second. Okay, so 60th part of a minute degree is 1 minute. 60th part of a degree, that is equals to 1 minute, and 60th part of 1 minute, this is equals to what, 1 second. Okay, so what is minute and what is second? That is the part of the angle. 1 degree, when it is being divided into 60 equal part, each part is known as what, 1 minute. And further, when 1 minute is divided into 60 equal part, okay, then each part is known as what, second. Okay, so this is all about minute and second. So under sexagesimal system, angles are measured in terms of degree. Okay, one right angle is equals to 90 degree, and 1 degree is equals to 60 minute. 1 minute is equals to 60 second. Okay, these are the part of the angle. It has nothing to do with the time. Okay, don't get confused. Okay, that as minute and second we are using, so it is related with time. Okay, it has nothing to do with the time. Now next is what, centesimal system. Okay, or French system. Now let us see that system. Second is centesimal system or French system. Or French system. Now, here one right angle, again we compare grades, okay, with right angle. One right angle, this is equals to 100 grades, okay. One grade is equals to 100 minute, 100 centesimal minute, okay, 100 centesimal minute, and 1 minute is equals to 100 centesimal seconds, 100 centesimal seconds, okay. So under this centesimal system, angles are measured in terms of grades. One right angle is equals to 100 grades, okay. One grade is equals to what? 100 minute. Again, similar to that of degree, what we do, that we divide this one grade in 100 equal parts, and each part is known as 1 centesimal minute, okay. When we combine those 100 centesimal minutes, okay, then one grade comes into existence, okay. Next to it, what we do, that we further divide this 1 minute. 1 minute means what? This is not the sexagesimal minute, this is centesimal minute. 1 centesimal minute is further divided into 100 equal parts, and each part is known as what? 1 centesimal second. That is, when 100 centesimal seconds are combined together, okay, then 1 minute comes into existence, okay. So centesimal system, within this system the angles are measured in terms of grades. How one right angle is associated with grades? When 100 grades are combined together, one right angle comes into existence, okay. One grade is equals to 100 minute, 1 minute is equals to 100 second. Here the minute and second which we are using, that is what? Centesimal minute, centesimal second, okay. If nothing is given there in the question, okay, several times it happens that the student get confused, okay. If nothing is given over there, okay, then you have to assume that the given minute is associated with the degree system, okay, that sexagesimal system. It is not associated with the centesimal system, okay, until and unless it is not mentioned that this is centesimal minute, okay. You will not consider the given minute as centesimal minute or given second as centesimal second, okay. Nothing is given there in the question, only this 10 minute is written there. It means that it is to be understood that this 10 minute is associated with the first system which we have discussed, okay, that sexagesimal system, okay. So this is all about centesimal system. Now see, one right angle is equals to 100 grades, okay, and one right angle is equals to 90 degree, okay. So now let us understand the relation between sexagesimal system and centesimal system. Now see, relation between sexagesimal system and centesimal system. Okay. Now what is the relation between sexagesimal system and centesimal system? As we have discussed right now that one right angle, that is equals to what? 90 degree. Also one right angle, this is equals to what? 100 grades. This 90 degree, it is representing one right angle. This 100 grades, this is representing one right angle. Okay, so this implies that 90 degree will be equals to what? 100 grades, or 1 degree will be equals to what? 100 upon 90 grades, or this 1 degree will be equals to 10 upon 9 grades. This is the relationship between degree and grade. Or we can say that d degree is equals to 10 by 9 d grades. Okay, suppose that the question comes that transform this 25 degree into grades. Okay, so d degree is equals to 10 by 9 into d grades. Just d has to be replaced by what? 25. Okay, if the question comes that what is the value of 25 degree in terms of grades, so you multiply this 25 from 10 by 9. Whatever value is coming, that is the grade representation of the given degree. Okay, in a similar manner, see this 90 degrees equals to 100 grade, or we can say that 100 grades is equals to what? 90 degree. This implies that 1 grade will be equals to what? 90 by 100 degree. This implies that 1 grade is equals to 9 by 10 degree. Okay, so if we have to determine the value of g grades, then g grades will be equals to what? 9 by 10 into g. 9 by 10 into g grades. Okay, so this g grade is equals to 9 by 10 into g degree. This g grades will be equals to 9 by 10 into g degree, and d degree will be equals to what? 10 by 9 into d grades. Okay, so either you remember this relation directly, okay, that is the question comes that what is the value of 62 grades, okay, then 62 grades in terms of degree. What is the value of 62 grades in terms of degree? Suppose that this is the question. Straight away you multiply this 62 from 9 by 10. Whatever value is coming, that is the degree representation of the given grade. At the same time, if the question comes that you express this 62 degree in terms of grade, straight away you multiply this 62 degree from 10 by 9. Okay, just reciprocal of this. Either you remember the relation, or you just learn that 90 degree is equals to 100 grades. Okay, so you determine, convert this degree into grade, that is 1 degree is equals to how much grades. Okay, and then you transform. It completely depends upon you. Either you remember that 90 degree is equals to 100 grades, okay, and using this concept you transform by applying simple unitary method, okay, or you just remember that d degree is equals to 10 by 9 d grades. Okay, using this you transform degree to grade, and g grades is equals to 9 by 10 into g grades. Using this relation you transform grade to degree. Okay, so this was the relation between degree and grades. Okay, now next to it, let us discuss the third system, that is circular system. Now see this circular system. Here, as we have discussed that angles are measured in terms of radian, okay, which is the SI unit of angle, radian. Now, before starting this circular system, let us discuss what is radian. Okay. Now, suppose that we take any circle, okay, of any radius. Okay, now let r is the radius of this circle, o is the center, o is the radius, which is equals to what? R unit. Now angle subtended by an arc of length equals to the length of radius of this circle. Okay, at the center is known as what? 1 radian. Okay, this is the definition of a radian. Again I am repeating it, that angle subtended by an arc of a circle whose length is equals to the length of radius of that circle at the center is known as what? 1 radian. Okay, that is, if the length of radius and length of the arc which is subtending angle there at the center, if these two are equals to each other, then within this condition the angle which is coming into existence there at the center, that is known as what? 1 radian. So this is the definition of radian. Okay, now the question must be coming in your mind that if there is a variation in radius, that is, if the small circle is there, larger circle is there, in all the conditions this 1 radian will be constant. Okay, it is. Okay, whatever is the length of the circle, okay, it does not matters. Condition is that radius and the arc, the length of these two must be equals to each other. Okay, and within this condition, whatever angle is coming to existence there at the center, that particular angle is known as what? 1 radian. We will prove it. Okay, that 1 radian is constant. Let us see that. One radian is constant. Okay, and relation between degree and radian. Okay, we'll prove that 1 radian is constant. At the same time, we will establish the relationship between degree and radian, that what is the relation between degree and radian. Okay, once we determine the relation between degree and radian, already we have the relation between grades and degree. So we will establish the relationship between degree, radian and grades. Okay, now let us prove that 1 radian is constant. Okay, now see. This AOB is a diameter, OB is the radius, okay, and this BOC, this is 1 radian, as we have considered the length of arc BC is equals to R. Okay, now from geometry one result comes that ratio of the angles subtended at the center, that is angle BOC and angle BA or BCA, angle BCA. Okay, here BOC, this is the central angle, okay, and BCA, its central angle is what? 180 degree. Okay, the ratio of the angles subtended at the center is equals to ratio of the arc which are subtending these angles at the center. Angle BOC is being subtended by arc BC. This is being subtended by arc BC. Okay, and wait, let this be BOC is one of the angle, BOA, angle BOA. Okay, BOA is being subtended by arc BCA. Arc BCA. Okay, is it clear to all of you? See here. From geometry, this result comes that ratio of the angles subtended there at the center, okay, the ratio of those two angles is equals to ratio of the arcs which are subtending these angles there at the center. So I have taken two angles, angle BOC and angle this BOA or angle this AOB. Okay, BOA. Now these two angles, the ratio of these two angles, that is equals to what? Ratio of the arcs subtending this angles there at the center. Angle BOC is being subtended by arc BC. So I have written here arc BC, and angle BOA is being subtended by arc BCA. Arc BCA. This is your B. Arc BCA. Okay. Now angle BOC. What is the measurement of angle BOC? By definition, we can say that this is equals to what? 1 radian. 1 radian. Okay. As length of arc BC and length of radius, they both are same, and the definition states that within this condition, if the angle comes into existence, that is known as what? 1 radian. Now angle BOA. Angle BOA, okay, see, this is a straight line, so its measurement will be equals to what? 180 degree. Now this is equals to, here arc BC, length of arc BC is equals to what? R. So arc BC can be replaced by R. Okay, arc BCA, arc BCA. Now see, this is the semi perimeter of this circle. So perimeter of a circle is what? 2 pi R. Okay, so semi perimeter will be equals to what? Pi R. Okay, now see, this R and R cancel, or 1 radian is equals to 180 degree upon pi. Okay, now see, we have determined the value of 1 radian. Okay, see, radian is represented by this small c, degree is represented by this knot. Okay, then grade small g, radian small c. Okay, this is the representation of degree. This is our representation of grades, and this is radian. Okay, so this is how we represent degree, grades and radian. Now see, 1 radian is equals to 180 degree. 180 degree is what? 180 degree is constant. Again, pi is what? Pi is constant. Okay, so 180 degree is constant, pi is constant. So ratio of constant by constant is what? Constant. So 1 radian is equals to constant. So we have proved that 1 radian is equals to what? Constant. Okay, we were supposed to prove 1 radian is constant. At the same time, we have to establish the relationship between radian and this degree. Okay, now see, this pi into 1 radian, that will be equals to what? Pi radian is equals to what? 180 degree. So 180 degree is equals to what? Pi radian. So this is the relationship between degree and radian. This implies that 1 degree is equals to pi upon 180 radian. Okay, 180 degree is equals to pi radian. So by simple unitary method, 1 degree will be equals to what? Pi upon 180 radian. Okay, or this implies that d degree is equals to pi d by 180 radian. Okay, suppose that the question comes that what is the value of 60 degree, okay, in terms of radian. Okay, 60 degree in terms of radian. So just now we have discussed that d degree is equals to what? Pi d by 180 radian. So 60 degree will be equals to what? Pi into 60 by 180 radian. This 60 degree is equals to, from this relation, d degree is equals to pi d upon 180 radian. So 60 degree will be equals to what? Pi into 60 upon 180 radian. Okay, so pi into 60 upon 180 radian. So 60 into 3. So this is equals to what? Pi by 3 radian. That is 60 degree is equals to what? Pi by 3 radian. So from now onwards, we will not represent the angle in terms of degree, okay, until and unless it is the requirement of the question. Okay, always we will express the angle in terms of SI unit. That is, we have to express the angle in terms of radian. Okay, because now we are familiar with the SI unit of angle. Till class 10 we were using degree, okay, for the measurement of angle, but now we will use this radian. Okay, in order to represent the angle, as this is the SI unit. Okay. Now next to it, let us again determine one more result from this concept. Now see, relation between theta, L and R. Now what is theta? The central angle, the angle which the arc subtends there at the center. L, the length of arc which is subtending theta angle there at the center, and R is what? Radius of the circle. Okay. Now what is the relation between theta, L and R? Now see, let us consider a circle, okay, whose radius is R unit, OA. Okay. Now let this arc AB, whose length is equals to the radius of the circle. Okay. So this arc AB will subtend 1 radian there at the center. Let AOC is angle theta, which is being subtended by arc AC, whose length is L. Okay. So just now we have discussed that from geometry one result comes that angle AOB upon angle AOB upon AOC, the ratio of these two angles will be equals to what? Length, ratio of the length of arc subtending these angles there at the center. So angle AOB, this angle is being subtended by arc AB, and AOC, this angle is being subtended by arc AC. Now this AOB, angle AOB is equals to what? 1 radian. Angle AOC, this is equals to what? Theta. And arc AB, its length is what? R. And arc AC, its length is what? L. Okay. Or this implies that theta is equals to L by R radian. So this is the relation between theta, L and R. Okay. So here we have established the relation between theta, L and R. Okay. Now next to it, let us establish the relation between degree, grades and radian. Now see, this is very important result, and here the theta which is coming into existence, it is expressed in terms of what? Radian. Okay. So don't get confused. Okay. Several times while correction we observe that the student, they use theta is equals to L by R, and whatever angle is coming into existence, they are expressing it in terms of what? Degree. Okay. That is not the degree measurement, that is the radian measurement. Okay. So important result is this. Okay. And we use this result while solving the numerical. I will discuss the questions based on this, all these results. Okay. But before coming to the numericals, okay, let us discuss the concerned theory. Now next to it, we'll establish the relation between this degree, grades and radian. Okay. Now see, relation between degree, grades and radian. Degree, grades and radian. Okay. Relation between degree, grades and radian. Now see, as we have discussed that 180 degree is equals to pi radian, or 1 degree will be equals to pi by 180 radian, or d degree will be equals to what? Pi d upon 180 radian. Okay. Now this part we have discussed. Now before coming to this part, let us consider an angle theta. Now let us assume that when this theta is expressed in terms of degree, its value comes d. When the theta is expressed in terms of grades, its value comes g. And when this theta is expressed in terms of radian, its value comes C. I hope that you all are getting this part. Theta is sum of the angle. Okay, the same angle. Suppose that I have to express my height. Okay, in terms of feet, meter, centimeter, kilometer, decimeter. My length will be fixed only, isn't it? It's true that in different units, different values will come, okay? But my length is constant, okay? So whatever values are coming in terms of feet, whatever values are coming in terms of this centimeter, meter, kilometer, decimeter, etc. All these values are representing my height only. Okay. So what is the relationship among those units? They all are equals to each other. In a similar manner, here theta is being expressed in different units. Theta, when it is expressed in terms of degree, its value is d. When the same angle theta is expressed in terms of grade, its value is g. When this theta is expressed in terms of radian, its value is c. Okay, all these three are representing the same angle theta. So what conclusion we can draw? That this d is equals to g is equals to c. Okay, this d is equals to g is equals to c. Now here theta, when it is expressed in terms of degree, see here, d degree is equals to what? Pi d by 180 radian. Okay, so this d degree we have transformed in terms of radian. Okay, this d is being transformed in terms of what? C. Now let us transform in terms of grades. Now see here, 180 degree, this can be written as one right angle into 2. One right angle is equals to what? 90 degree, and 90 degree into 2, this is equals to what? Pi radian. Okay, and as we have discussed that one right angle is equals to how much grades? 100 grades. So this 100 grades into 2, this is equals to what? Pi radian. Or 200 grades, this 200 grades, this is equals to what? Pi radian. Okay, or 1 grade, or this 1 grade will be equals to this pi upon 200 radian, or g grades is equals to pi g upon 200 radian. Okay, so we have expressed this g grades in terms of radian. What we have assumed? That theta is equals to d degree, and we have expressed this d degree in terms of radian. What we have assumed? That this theta is equals to g grades, and we have expressed this g grades in terms of radian. How we have expressed, that part is clear. Just now we have discussed that 180 degree is equals to pi radian. So 1 degree is equals to pi upon 180 radian. Okay, by Newton method. Or d degree will be equals to what? Pi d upon 180 radian. So the value of this d degree in terms of grade, and we have assumed that this theta is equals to what? D degree. Okay, so this d degree is transformed in terms of grade. In a similar manner, 180 degree can be written as one right angle into 2. Okay, as one right angle is equals to 90 degree. 90 into 2, 180 degree is equals to pi radian. And from definition we know that one right angle is equals to how much grades? 100 grades. So 100 into 2, that is 200 grades, is equals to pi radian. So again by unitary method, 1 grade will be equals to what? Pi upon 200 radian. Or g grades will be equals to what? Pi g upon 200 radian. So this d degree we have transformed in terms of grade, sorry, radian. This g grades we have transformed in terms of radian. And the third one is already the radian representation. So we can say that as this d is equals to g is equals to c, okay, as these three are representing the same angle, okay, according to question, here according to question, this d is equals to g is equals to c. So at the place of d we can write, just now I have explained here, that pi d by 180, isn't it? 100 degree is equals to pi radian, 1 degree is equals to pi by 180 radian, d degree is equals to pi d by 180 radian. Okay, so this, at the place of this d we have written pi d by 180 radian, as we have expressed this in terms of radian. Now g grades is equals to pi g by 200 radian, and this is equals to what? C. Okay, now this has been expressed in terms of radian, this has been expressed in terms of radian, and C, this is already the radian measurement. Okay, as all these three are equal, so C will be equals to what? These two. Okay, now if we divide all the terms from pi. What value will come? D by 180, G by 200, C by pi. So this is the relationship between D degree, G grades and C radian. Okay. So in this video we'll discuss up to here. In next video I will share the numericals based on these theorems. Thank you.